Why, hello there, lovely one. It's me, Helen the Great, and we're going to go through a summary of what we've done in the section Functions. Now, obviously, it's a huge section, so we're not going to cover everything. Just go over it in point form. Now, I've divided up the summary into 3 sections. First, plotting a function, then looking at the different functions, and lastly, interpreting a function. So when we plot a function, we first need to determine the shape. What kind of shape is it? Is it going to be a straight line? Is it going to be a parabola? Is it going to be a hyperbola or an exponential graph? After we've done that, then we need to do our x-intercepts and our y-intercepts. And of course, we know by now that in order to find the x-intercept, you've got to make y equal to 0. And in order to find the y-intercept, you've got to make x equal to 0. Remember that 2 of the functions have asymptotes, hyperbolas and exponential functions. So you also need to, for those 2, determine what the asymptotes are. Now, as you are determining these 3 things, sometimes 2, you need to plot them on the Cartesian plane as you're doing them. Remember, you're not expected to be completely accurate, so that's fine. Now, if you are struggling to use all of those, and we know that exam pressure can be difficult, then resort to the beginning method you used, which is the table method. When you find a list of coordinates by using a table, let's draw it like that. You have your plug-in values, which are x, and your output values, which are y. I would start with -2, -1, and then go all the way up to +2. And then at least you've got some coordinates to plot. Listen, it's not going to be perfect, because you will need to draw the right shape. But at least you'll be able to do something that looks like what you need to have. Okay, well that's the end of part 1. Let's go look at part 2, which was, looking at the different functions. So I have this beautiful table here that I really like using to describe all of the functions. Obviously over here we have a linear function. How do we know it's a linear function? Because x is to the power of 1. Remember that all the shapes are determined by what's happening to x. The next one we have is a quadratic function, which forms a parabola shape. How do we know it's a quadratic function? Well, x is to the power of 2. The next one forms a hyperbola shape. Let's just call it hyper. And the reason we know it's a hyperbola is because x is in the denominator. And lastly, we have an exponential function. And how do we know it's an exponential function? Because x is in the exponent position. Now, obviously, linear functions are going to be straight lines. Quadratics are going to be parabolas, then hyperbolas form this cool 2-part function. And the reason why it forms a 2-part function is because it has 2 asymptotes. And that's quite nice. Remember, an asymptote is a line that the function will continue to approach but never, ever, ever touch. Then lastly, we have an exponential function which has 1 asymptote. It's pretty important that you know what each one of these variables does to the equation. And that's why I like this. Now, let's start with the first thing, where a is more than 0. That's a fancy way of saying a is positive. I've kept q at 0 and b, that only applies to this last one, b is more than 1. So in the first one, the linear function, when a is positive, our straight line is going to go up, but it's still going to go through a value of 0 because q is 0, and as we know, q is the y-intercept. With the quadratic function, q is also the y-intercept again. If a is positive, then the parabola is going to smile. And look, there it is, and going through the point 0, 0. A hyperbola, if a is positive, it means it's going to fall in the first and third quadrant. Yep, first and third quadrant. And because q is equals to 0, our asymptote falls on the line y is equals to 0. Remember, we also have an asymptote of x is equals to 0. Then lastly, the exponential function. If a is more than 0 and b is more than 1, it means that the function is going to be above the asymptote, and because b is more than 1, it's going to move away from the asymptote. In other words, it's getting bigger and bigger and bigger the whole time. But now, if we change a to be a negative number, look, I've kept everything else the same. So I'm just changing a from a positive number to a negative number. Look at the effect it has. When a was positive, the straight line went up. When a is negative, the straight line goes down. When a is positive, the parabola smiles. When a is negative, it frowns. When a is positive, the hyperbola is in the first and third. But when a is negative, it's in the second and fourth. And lastly, when a is positive, the function is above the asymptote of the exponential function, and when it's negative, it's below the asymptote. Now look, b is still more than 1, and you see how in the first one, b was moving away from the asymptote. Look, in the second one, it's also moving away from the asymptote. Alright, now let's look at the third column. Well, I suppose it's the fourth one, but it's the third change. You'll notice that a is still going to be more than 0. So that stays the same. In other words, we're expecting the straight line to go up, the parabola to smile, first and third quadrant, and the exponential function to be above the asymptote. But now what we've changed is that q is going to be more than 0. We know that q in the linear function is the y-intercept. And look, over here, q is more than 0, so the y-intercept is more than 0. It's gone up. In the parabola, q is more than 0, q is the y-intercept, so it's above the x-axis. Once again, the asymptote has moved up for the hyperbola, and the asymptote has moved up for the exponential function as well. We're going to keep a the same in the next one, but now we're going to change the value of q. It's now going to be less than 0. What does that do to the function? It moves it down, moves it down, moves it down, and moves it down. Not bad. So for the first 3 functions, we've examined what each one of the variables does to the equation, or at least the picture of the graph. For the last 2, it only applies to the exponential function. And the reason why it applies to the exponential function only is because we're looking at what the value of b does to the graph. Remember, when b is more than 1, it's always going to move away from the asymptote. But now b is less than 1. So that means it starts moving towards the asymptote. When it's above the asymptote, it looks like the function's going down. And when it's below the asymptote, it looks like the function is going up. But I find that quite confusing. So I rather think when b is less than 1, the function approaches the asymptote, no matter whether it is above or below. Okay, well that's the end of part 2. The part 3 is really where most of your exam questions are going to come from. So let's scroll along. And remember, this is the last thing I'm going to go through. And then I think we've revised enough about functions. When interpreting functions, there are a couple of things they're going to ask you. One of the favorite ones is determine the equation of the function. They may not give you all of the information, you may have to try and figure out what the y-intercept is by using the other equation that's on there. Remember, interpreting functions are usually two functions on the same set of axes. So you may need to use the one to determine the equation of the other by figuring out or using the points over there and over there. Now, speaking about those 2 points, those are called the points of intersection. And in order to find those points of intersection, let's see if I can spell it right, intersection, oh, it's looking good, you need to use simultaneous equations. That's when you substitute the one into the other and solve for x and y simultaneously. Be careful, if there are 2 points of intersection, like over here and over here, you're going to get 2 different coordinates. So watch out, make sure that you write them as coordinates once you're done with that. Now, the other thing you'll be asked to do is to determine the x-intercepts and the y-intercepts and the asymptotes. All of those you will have practiced quite a bit in other exam papers. And that's really important that you only study from exam papers. Now, lastly, you'll be asked to find or define the domain, the range, and where things are increasing and decreasing. Remember that that domain are all the values for which it exists, all the x values. And the range are all the y values for where the function exists. For example, let's go back to this parabola. The domain, well, it's going to go on forever and ever and ever, so that means x is an element of any real number, and that'll be true for most of your functions. But your range only goes up from that part. So let's say that's at -1. Your range is only going to be more than or equal to -1. Well, this is a very brief summary of the functions. Please remember you must only practice from exam papers. The stuff that you do in class and in your textbook are far too easy, so go over exam papers over and over again. That's it for now. Much love.